The last video for section 115 discusses joint variation. In this case, we're going to be dealing with three variables, x, y, and z. So x is said to vary jointly with y and z if there is a proportionality constant k such that k is equal to x divided by the product of y and z. So essentially it varies directly with the product of the other two values. So Coulomb's law for magnetism states that the force F between two magnetic poles varies jointly with the strength S1 and S2. So let's just start there. The force varies jointly, so we're going to divide by both of these, S1 and S2. And it varies inversely with the square of their distance apart, d. So if we simplify this, this would be f d squared over s1 and s2. And again, these numbers here are subscripts, not exponents. So you see over here, already written is another version of this. If we just solved exclusively for f, we would multiply the s1 and s2 over and divide by the d squared, and we get the formula that's written in the box on the left. We'll try one example of this. Newton's law of universal gravitation states the gravitational force F between two objects varies jointly with their masses. So in this case, K is equal to F divided by M1, M2, so this is looking similar to the last one, and inversely with the square of the distance. So again, times r squared, because inverse is going to multiply. So if we simplify, this is f r squared over m1, m2. And now we're talking about large objects, so these numbers are going to be large and involve scientific notation, so it gives us a bit of a review of that as well. So if we are given, for instance, the force is 1.98 times 10 to the 20th, and we are dividing that by m1, which is 5.97 times 10 to the 24th, and we're also dividing by m2, which is 7.35 times 10 to the 22nd, and then r in this case, so this is going to be in the numerator, 3.84 times 10 to the 8th, and then we need to square that number. We want to find f when m1 is 5.97 times 10 to the 24th, m2 is 1.90 times 10 to the 27th, and r is 7.95 times 10 to the 11th. And again, we need to square that because we have r squared. So let's go to our calculators to remember how we do scientific notation. Now, in your calculator, you will see this button here which says EE. This is what we use for scientific notation. So if, for instance, we wanted to put this entire left-hand side in all at once, so we need to start off with parentheses, 1.98, and we're going to use this e to the 20. So we don't need to write the times 10 and the exponent. We can just put this e button in for shorthand. Times, and I'm going to put this in parentheses because we need to square it, 3.84 e to the 8th. Again, that's all we need to put. I'm going to close this, square it, and then close the parentheses to complete the top. Then divided by, open parentheses, 5.97. Again, we have our e to the 24th times 7.35 e to the 22nd. Close the parentheses for the denominator, and we can hit enter and see that we get 6.65 times 10 to the negative 11th. I want you to practice now, pause the video, and practice how you would put this in for the right-hand side. So in this case, we only have the 7.95 times 10 to the 11th squared divided by both of those numbers. And again, remember your parentheses. So you should have found on this other side that you get 5.57 times 10 to the negative 29th and times f. So now we need to divide these two by the 5.57 times 10 to the negative 29th. And again, if we go back to our calculator, we have our I'm going to use a few more decimal places, 6.537. Again, I'm just kind of looking up here. We have our e to the negative 11th divided by 5.5719. We could have just used second answer. E to the negative 29th. If we use second answer, we don't have to type all this in. And we end up with 1.19 times 10 to the 18th. So in this case, the force ends up being 1.19 times 10 to the 18th. And our units in this case are newtons. And this makes sense. It's comparable to what was given of 1.98 times 10 to the 20th. This is off by a factor of 2, or it's different by a factor of 2 in our exponent there. So this concludes the video for section 1.15. Please go online and complete your homework for this section, and then view the video for section 14.1.